Okay, thanks for coming along. I guess my name is Chris Chedgey. I'm with a small company called Structure 101, and we've been in this kind of area of structure and architecture and how do you recover architecture for a long time, since about the year 2000, in fact, in one form or another. And so what I want to talk about today is, where's your architecture? What I mean by that is, I guess back in the 90s or whatever, I remember Tom Schultz, who was the product manager for Rational Rows. Anyone remember Rational Rows? Anyone remember UML? Okay, good. At those days, I guess we were kind of coming out of the waterfall. How do we kind of somehow build big systems without it just becoming a big disaster, a big mess? And the answer became more control, right? We've got to just do more requirements analysis. And we don't touch anything till we finish the requirements analysis. And then we go into design, and we do design phases and have design reviews, etc. And UML came along, and it was kind of in the middle there. And it was kind of funny because it had this concept of round-trip engineering, where you kind of do both design and implementation at the same time. And Tom Schultz came out, I guess it might have been around Bill Clinton's time. So anyway, he came up with this expression, "It's the code, stupid," right? This was the problem. We forgot the thing we were building, okay? It's the code, okay? And I guess that was probably, I like to think that was the kind of the beginning. Certainly it's, whether it's coincidental or influential. After that, we started getting more into code-centric processes, and agile really is the essence of that. The quality comes from the code base. Your code base is your crown jewels. We got to keep that code base fresh, continuously refactor, continuously test first sometimes. Okay. But I think, and that's great. And I think our industry has moved on really nicely since those days, right? We now do agile development, very tight iterations. You've got the user in the loop. You've got continuous build, continuous deployment. You've got continuous test. And the code itself and the quality of the deployed product is kind of maintained at all times, which is great. Okay. But I think I'd like to kind of think now is the time to stop and look back and say, hold on a minute. Okay, your code is great, it works. Okay. But it's the code base we need to look at now. Okay. The architecture, if you like, I'm a bit uncomfortable with the term architecture, but what I mean is, at a macro scale, how are we organizing those millions of lines of code? Okay, we're doing a great job down at the level of handfuls of classes, little islands of classes, little small worlds of classes and patterns and what have you. And that's what we kind of focus in on when we're doing design, okay? When we're using patterns, that type of thing. When we're doing refactoring, we're thinking largely at that level. But I think there's a big cost to that. There's a huge cost to that. And it's the lack of architecture, some higher level abstractions that we're missing. Okay. So that's what I've dedicated, if you like, a large part of the last 14 years of my life to. I think it's a topic that is, for me, very interesting, but I think possibly very important to our industry. If we can start really maintaining code, but in an agile way, not going back to big design up front, not going back to waterfall, but in an agile way, keep your architecture, the overall shape of your code base, part of that agile iterative development process. That's where we want to get to. So I'm just going to switch over to my own slide deck here. Okay. Hello. Thank you. Now, so what I'm going to talk about today is just going to talk a bit about architecture. What is this architecture thing? I said I'm uncomfortable with it. What I really mean is an organization to your code base. Let's talk a bit about that. And why is it important? Why would you give a damn about the shape of your code base? Why should it be organized? What do you have today? Okay, you're all working, I'm presuming most people are kind of involved in large-ish code bases pretty much every day, because small greenfield code bases don't stay that way for very long. So statistically, you're working on a large code base. Okay, what is it you need really? Okay, and where did it go? Okay, I'm guessing any of you who have worked on greenfield projects, you generally do start off with something that has a bit of shape. You don't just charge in and start developing classes. You kind of have a bit of a vision. Where did that go? And I'm going to show you a bit of an example of where it goes. And how are you going to get it back? Now, this is the key thing. This is kind of my passion, right? It's all very well saying we should do architecture of some sort up front and control it, prevent cyclic dependencies and all that sort of thing. But that's not going to happen, right? That doesn't happen. Okay. Problem is, when the code base is small, you don't need all that stuff. Okay. You don't need to be dragging around an architecture, have big architectural discussions or what have you. Okay. You need to be agile. You need to figure out what is the nature of the thing you're building, for the most part, right? You're going to put some sort of constraints on it. But how do we get it back? Okay, that's the real fun bit. My company built a product called Structure 101, and I'm going to make some of this make some sort of sense, hopefully by showing you the product at the end. Actually, the product itself isn't particularly important. There are other great products out there. If you're interested in this sort of thing, take a look at Sonograph, take a look at Ladix. There are other ones out there that do this kind of thing. You do need some sort of tools, okay? But it's the principles that count. And I think the tools are in place now that with the application of certain principles, you can actually salvage a code base, okay? You can make it much easier to develop going forward. So, and with any luck, there'll be a bit of time for questions at the end. Okay. So let's start here. What is architecture? Well, that kind of thing that looks a bit like the microwave background radiation chart is supposed to represent a code base at the implementation level, if you like. So what you have there is, and an architecture is intended to organize all of those interdependent files and classes and what have you into some sort of higher level abstractions. Okay. The one thing that they have in common, they're all different. You'll see lots of these pictures. They're all boxes and lines. That's the first thing they have in common. The second thing they have in common is they tend to represent a containment model of some sort. So the idea is that each of the boxes kind of contains some subset of the code that's in your code base. And they're well organized because those subsets, those groups of code, those architectural components depend on each other in some sort of well organized way. It's not a free-for-all. It's not everything using everything. Okay? It's you're trying to minimize, you're trying to root and contain the dependencies, contain the coupling. Okay? And there's also the concept of dependency rules. Okay? So there's this crossover, which is quite interesting, which is here is my architecture, if you like, but what should it be? Okay? So there is the intent not just of this is what uses what. It mightn't today, but one day it will, and it's allowed to, it's part of my architecture. Okay? What makes it real? So pretty pictures we've all seen in documents, on whiteboards, on your wikis, whatever. What makes it real? Okay? Two things you need to make it real. One is you need to map the architecture to the code. Okay? There's no way around this. There is no point having boxes when you don't know what those boxes really are. Okay? They're just boxes then. Okay? It needs to map. It needs to be explicit and well understood. What is the code that maps to each of those boxes in your architecture, if you like? And then the second thing you need to do is make sure that that is in fact true. You need to validate it. Okay? So ultimately, this needs tools. You need some sort of tools to do this because you've got, 20,000 classes. You've got, 2 million lines of code. You need to be able to do this continuously all the time. Okay? Why would you bother with this stuff? Okay. Well, I don't know. I mean, I think intuitively, as sort of experienced engineers, you've all been through probably software engineering 101, whatever. You need some sort of a map. You need some sort of higher level abstraction so you can understand what's going on. When you can understand the code base, it's a very human It's a very human activity, and humans need to be able to understand it. So we need a map or a blueprint for the code base. If you've got a well-organized architecture, you can now start doing things like phasing your testing and release. So your code base has got to a certain size, okay? I want to be able to just test a component, release that component to the other components that use it, okay? I can't do that if everything uses everything. Likewise, I can't divide the work. I can't really work in parallel very well if I've got just a code base where everything uses everything, okay? And that could be across organizations, teams, or individuals, right? You need some sort of structure there with understood dependencies so that people can work in parallel on those components. You've got the benefits of modularity, okay? All the time, we're building classes. We're hiding stuff on the inside. We're making some stuff private to a class so that we can change it, so that everything isn't impacted all the time, okay? We should be able to have that at the level of multiple classes at higher levels. You might want to be able to reuse or replace things. You certainly can't do that if everything uses everything. You need some sort of control over change. You need to be able to help new developers when they come in. What do your new developers do today? You give them a desk with a computer and an IDE. They're going to start looking or finding their way around somehow or other. Mostly what they're doing is taking a drain on all your existing or your current developers. So I like this term agile engineering, because engineering kind of puts people off. They start thinking in terms of hardware processes with waterfall and that type of thing. But no, this is agile engineering. You're adding some engineering discipline to your overall development process, and at the same time becoming more agile. Right? You can start putting new features into your code base much quicker. So what do you have today? For sure, you have this. You have the microwave background radiation map, which is lots of files with code in it, okay? And they're all interdependent. It's quite a complex thing, okay? And this is what needs an architecture. I don't think many would argue that just working at this level is a great idea, okay? That's where you start. When it gets to beyond a certain size, you need something else, okay? The other thing you will have is some sort of physical organization. So if you're working in Java, you've got the package structure, you've got jars, you've got Maven projects, that type of thing. Okay? And that does help your developers it's a bit of a roadmap, helps them find stuff to get used to where things are, and there's a clue there as to the intent. Okay? But is it what you would call an architecture? Okay? So let's take a bit of a closer look. I've sort of made that tree view two-dimensional there. And what really is of interest is what are the dependencies here? Okay? And the reason the dependencies are interesting is because that's what makes code complex. Right? Otherwise, we wouldn't have a problem if there weren't dependencies between all these bloody lines of code. Okay? We wouldn't have a big problem. Okay? And if you look in a bit closer there, what you typically have is something like that. So unless you have been monitoring your code from the start of the project, it's probably going to look a bit like this. Okay? And the problem there is that, I'll give you an example now as to why that kind of is a problem, I guess. But again, it's to do with the complexity and the change impact whenever you make a change, and the understanding of the code and what you're going to change where, and what is the flow of dependencies, and all those things we put on that chart earlier on. You can't do it with that. Okay. So let me just take a quick look across here at this here. So this is a dependency diagram of the Spring framework. Okay. The Spring guys from the very start said, okay, whatever you think about your architecture, we're not going to have any cyclic dependencies. So there are no cyclic dependencies here. This is laid out so all the dependencies flow downward, okay? And I'm just going to switch off the dependencies now, just to make it a bit clearer what's going on. And very quickly, I just want to give an example here. I mean, I hope it's not too much motherhood and apple pie, but it gives a good, why are we doing this stuff? So I'm just going to select everything that could be impacted if I were to change that HTTP element there. Okay? I'm just going to mark them there so we can see them. And you can see here there's 8 items. If HTTP changes, there's 8 items that could get impacted, directly or indirectly. Okay? I'll try one thing. Now I'm going to add in one dependency here. And it's appearing on the chart because it's not flowing down. There's lots of other dependencies that flow down. This one flows up Okay, so I've created a cyclic dependency. Someone working on util has put in a call up to some code up in EJB for whatever reason. Okay, and what's the impact of that? Now when we do the same thing here, I'm going to select the use by. Okay, just tag them. Now you can see the impact of that. Now when HTTP changes, okay, it's not just the 8 or so things, it's 25 things that get affected. Okay. Now you're thinking, well, yeah, you just added one dependency, take out that dependency, you shouldn't have done that. The thing is, you didn't realize this at the time. Unless you're monitoring it, you have hundreds or thousands of these dependencies and everything becomes a big tangled mess. Okay, so I now no longer have the ability to predictably update things. I have a much lesser of an understanding of how my code base is going to change when I change something inside HTTP. What's the impact of that? And you get into the really common scenario where you make a change and then you see what breaks, and then you go to the next one, you find it, and then you're back to where you started. And you get into this big loop, and when you're finished, you're finished. Okay, but there's no real understanding at a code base level as to how that's going to impact other teams or other developers or what have you. Okay, so that's just a quick segue there. Okay. So yeah, we wouldn't normally consider what your physical organization, unless you've been monitoring it, it isn't usually what you would consider an architecture. It's going to be highly tangled, okay, and it's going to have no rules associated with it. It just is what it is. Okay, so that's two things we have. What do we need? Well, as I say, we have the code, and we have one organization of that code here. Okay, so we do have containment going on here. But the problem is that we don't have very good containment. So what we really need is something else, which I'm going to call architecture. Okay, but it's basically a containment model with which the developers, it helps them with all those kind of things they need, and we can check that the code base conforms to it, and we can make the physical structure align to it if that's what we want to do. Okay, so what is this thing? So the thing on the left has no containment. Okay, that's one extreme here. We need some containment. We need abstractions. Okay, and we need to have, not just two. If you got like 20,000 classes, we don't want two 10,000 class components, right? We need sort of whatever, 20, 30, 40, 50 classes in each container, right? Not too much stuff, enough that I can just understand, but we need them organized into containers so that there are no cyclic dependencies. Okay, we need it to map to the code, and we need to define some rules. Okay. So how are we going to get that? Well, we're going to go to the two sources, the two things you have today in your code base. Okay. You've got the source files and their dependencies, and you've got the physical organization. Okay. And we're going to use those two to find our architecture. Okay. So now I just want to take a little bit of a diversion here. Where did it go? Okay. Where did that architecture go? I bet you one day your architecture looked a bit like this if you started on a new project. This is the Finebugs project, actually, which I'm not picking on so much as it just happened to be that they had lots of builds that demonstrate my point quite well. So this was how it looked way back in March 2004, and that's how it was October 2004. So it's growing, you can see, but you have this sort of orderly dependency structure going on. By April 2005, you can see these two packages here became tightly coupled. Okay, and it's not like there's, one is really mostly depending on the other. It's about the same. Okay, they're equally dependent on each other. So now, when you make a change, you want to add a new analysis or something like that, chances are you're going to have to add something into config. And when you make some change in config, you're probably going to have to change stuff in Finebugs, etc. These two have become a single component from an architectural point of view, from a comprehension point of view, from a testing point of view, all those things that were on the chart. Okay. Going forward in time now, you can see that the BA package has been sucked into this tangle. And where it used to be a clean one-way dependency from Finebugs to BA, there's now this dependency back here to from the other direction, where BA is starting to use dependencies, use stuff inside BA. And of course, at that point, it would have been quite easy to fix, but by the next build, I think it's up to 99 is the number of references inside BA on to find bugs. And that's quite common. Once stuff starts to use in a direction you don't particularly want, the chances are that'll just escalate as the code base grows. Okay? And as time went on, you can see that more and more stuff went into the code base and more stuff got sucked into this tangled region. Okay? So that's, I mean, I would say most code bases, if you had the luxury of the time to do it and you were to look at the top level package breakout, you'd probably see something like this. So what is well-structured containment? Well, it's containment. Okay, containment. We need containment. Okay, we use containment all the time, and we have to, because otherwise we'd be just dealing with millions of lines of code in one big mess of some sort, right? But we can't do that. That's just not possible. Okay, we need to divide and conquer. Okay, so we take the code, we group lines of code into methods, into classes, into packages, into subsystems, into Maven projects, into whatever, right? We continue to do that, and we have to do that. Okay, we have no choice. It's too complex for our little minds to cope with otherwise. I use the term fat for too much stuff in one place. Okay, so as your code base grows, your method gets too big. What do? Well, you extract method. You take that little block out of the middle of the for loop and you stick it into its own method. Now I can understand the original much better, and I've got a thing that I can reuse over here. Okay, it's great. I do that all the time. So that's, you know, grow and divide. Problem is, the containment creates dependencies. So here's a code base of some sort, okay? And here are two containment models for the same code. Okay? So I just put the same code into, just arranged it differently into some packages or whatever these things are, buckets of stuff, okay? And you can see the one on the left, containment model 1, is considerably considerably simpler than containment model 2. It's kind of an exponential thing as well. Okay, so it's not just a little bit. It's not like there are twice as many dependencies, therefore it's twice as complex. It tends to be much more damaging than that, to my mind. Okay. So, containment creates dependency. Dependency creates complexity. Roger Sessions, lovely quotes here. Law 3, complexity is driven by interdependencies. Okay. He's saying the complexity at your code base level is about dependencies. And then he says complexity is an undesirable architectural attribute of an IT system, which sounds like a bit of an understatement when he goes on and lists all the things it's bad for. Okay, reliability, auditability, security, alignment, cloud, maintainability, agility, and scalability. Okay. So dependency creates complexity. Okay. Cycles explode dependency and thereby complexity. Okay. John Lakos. Anyone ever hear of John Lakos? More of a C++ guy. But anyway, it's not a C++ specific measure. It's a cumulative component dependency. Is a measure he came up with, which is sort of is a really good measure for understanding the connectedness of a containment structure of any sort. Okay. And for this one here on the left, it's about 164. Probably a bit less, I didn't count, but exactly, but it's about that. That one dependency that we put in, which makes everything cyclically dependent, shoves it way up an order of magnitude. Okay? The whole thing becomes a lot more complex. Okay? So just to summarize then, what is well-structured containment? So we want to take our big code base and we want to hierarchically organize it into containers so that there are no tangled containers, but there's no fat containers. Okay. This balancing act between fat and tangles is an important one. You can very easily say, I'm going to have no tangled containers by putting all of your files into one big container. Okay. You can also say, I'm not going to have no fat containers by taking that big fat container and dividing it alphabetically into smaller containers. Okay. Neither of those help, because the second one will give you a really tangled structure. And you know, a lot of the time when I'm working with customers to disentangle a code base, you'll find yourself making things a lot better. You're getting rid of tangles, but actually what you're doing is you're picking up a whole heap of code in big buckets somewhere. So you need to monitor the two of them side by side. And once you have just that much, if you could have a containment structure for your million lines of code or whatever you have, where you can look in any bucket, any container, and there is a mind-sized chunk of stuff, you can understand it. Any of your team can understand what's in there, okay, at the next level breakout. Okay? And there are no cyclic dependencies between your containers. Okay? You have made huge progress at that point. You're in the sort of top percentile. Okay? And that gives you a foundation for all this other good stuff you can do. Now you can start defining rules. It makes sense to define rules. It doesn't really make sense to define rules when everything's a big cyclic dependency mess. Okay? You can enforce, you can control it, and that type of thing. Okay? So that tends to be a big first step. Okay, so get a bit more concrete then. Going to show you Structure 101, the stuff that we use, the sort of technologies we have developed in order to make this stuff possible. As I say, there are other things out there that do things similar but different. Okay. First thing we've defined, and you'll find any of this kind of category of technology will have something like this. We call ours is a levelized structure map. LaTeX uses dependency matrices for this type of thing. Okay. But you need some way to model all of the dependencies in your code base, probably millions of them. Okay. But model them so they roll up through some sort of containment structure. So there's a lot involved there in just making it possible to do it at all, but also filtering it so you can do anything with it, so you can understand it enough in order to manipulate this model. Okay. So we call it the levelized structure map. Okay. We designed it specifically for containment modeling. We built this a couple of years ago just for this purpose. We needed something like this, and there was nothing else that had been done along these lines that we were happy with. Okay. You can expand and collapse down through this LSM to any level you want. So you can drill down inside here. We've drilled, these are opened, expanded packages. Okay, and inside those we've got an expanded class, and you can see inside the class you've got the methods and fields. You know, these other packages here and these classes, they can all be expanded and collapsed. So there's just a few of them have been expanded here to give you the idea. Auto grouping is really powerful because they've got this concept of levelization. Levelization means that as far as possible, the dependencies flow downward. Okay, and we can kind of use that so that you don't actually have to show. You saw earlier on, I didn't actually need to show all the dependencies all the time. You can actually switch them off because you know the dependency flow is down, and then you can dive in and you can say, well, show me the specific dependencies when I need to. And it also means that we can do these things. Auto grouping makes a lot of sense. So I can group stuff and see where that group belongs in the fully levelized structure. Okay, so an example there is the tangle here. This red box here, the group of tangled items. There is a strongly connected component in graph theory is what they call it. And it basically means that there is a dependency path from every item in that tangle to every other item in the tangle. Okay? It's really good to focus in on that particular structural anti-pattern, if you like, when you're disentangling. Okay? Here's a couple of other ones. You see there's boxes around these. These are not really part of the model. They're not containers in the sense. What they are is groups of items. It's purely a visual aid, but I can see that these three classes here on the left are in their own this box that Structure 101 has put them into, and there's another couple over here on the right, and because they're on the same row, I know immediately by looking at it there are no dependencies between these two. So I can do things. I can start moving these guys out of here because I know there's no impact to be considered in terms of what's the impact on the other things. If you've got big groups of things together in the one and there's no dependency between them, should they be split out? Okay, do they need to be in the one place? Okay. Lots of filtering support. This is a chart that as you're making changes in Structure 101, you'll see the impact on this chart here. And what it's measuring is the percentage of the code base that's in a tangle and the percentage of the code base that's fat. Okay, and again, I told you earlier on about the balancing act between there, and you'll quite often see, well, you got rid of a tangle, but guess what? You got a bit fatter here because the way you got rid of that tangle was by making something too big, right? So we got to partition that again. Okay, but anyway, the point being that you can make manipulations either interactively through your analysis as an architect, as a guy who understands the code. You can move things around in this containment model, which you may be thinking of as your package structure or something. And watch this, hopefully watch this over complexity number move down towards the origin. And we also have some automatic ways to do that. So you need that, right? There's no point just moving things around. You need some kind of feedback. Is it getting more or less complex? Okay, so that's what that's about. The other thing to remember, as you'll see in the levelized structure map, as you make all these changes, it's continuously re-levelizing. Okay, so that means it figures out again, well, what belongs on the bottom. Or you made a change here. How do my containers float relative to each other in the dependency levels? Okay. Second thing you're going to see, which is, I guess, different to Structure 101, are these architecture diagrams, which we pulled out. They're separate from the LSM, but they map to the LSM. So it's a divide and conquer kind of process. First thing you're going to do probably is reorganize your code into some sort of containment model that makes some sort of sense. Then you're going to start thinking, well, how much of that do I really care about? And you're going to document that in these architecture diagrams, which will be visible to the team, and it'll be checked against the code at edit time, build time, what have you. And they also, at the same time, define some rules. So it's not just saying, here's your code, here's the shape of it, but it's saying a lot about what is allowed to depend on what. Okay. The key is that each of these cells here maps to a subset of the code. Okay. So it could be thousands or hundreds or two or one or something, classes mapping to each of these cells. And then the cells themselves, the relative positioning of the cells describes some rules. Okay, so the default semantics is the dependency should flow downward. You can override that and what have you. You can also apply visibility constraints. You can say this is hidden to the parent scope. You can do that kind of thing. Okay, but between the two, you're really saying, you got 2,000 classes in under here. You got 40,000 here. You got 6,000 here. You got 100 here. Whatever. There's a whole lot of dependency rules being checked all the time. Okay, there's anything in here, can't use that, can't use that, can't use anything in here. This can use that, but etc. You get the message, right? You can have many diagrams, which is important if you've got a large code base. You're not going to try and squeeze everything into one big diagram. Key here is that you define the diagrams. Okay, you can get Structure 101 to initialize them based on what's there today, and you might be perfectly happy to leave it at that. Okay, but it won't change as the code changes. Okay, that would be like the law changing when people break it, so that you change it so they didn't just break the law, right? That's not the architecture diagrams are prescriptive. You put in here the things that you care about, and it forces you to think about that. Okay. What will change are these lines here. These are violations on the diagram. Okay, this one's a violation because it's going upward. These two are violations because they are dependencies on a private cell that shouldn't be used outside of the red box here. Okay, that will change. The code will change, right? And as the code changes, we'll check that the rules, the diagram is still being respected. Okay, and this can be done at edit and build time. Okay, so they're the two main artifacts that I'm going to show you. There are two steps to getting from your code base, which is doesn't have an architecture, to one that does. And the first one is discover and define your architecture. Okay, so there's typically a bootstrap step. Okay, you're going to use the LSM to create your well-structured containment model. Then you're going to use the architecture diagrams to define the dependency rules. Okay, then you're going to share your architecture and move on to step 2, which is continued development, architecture guided development, if you like. But it's architecture in the loop now, okay? So where your developers' only job, of course, is to sit there in their IDE and churn out code, which they spew into the code base. They are now, you have somebody wearing the architect's hat, which is probably just another team member, developer, senior developer, whatever. Maybe everybody's doing it. Inside ADE, an architecture development environment, if you like, generating action this architecture diagrams rules. Okay, And that now feeds into the development process. So the guy, as he's making changes here, should know immediately if he's added a new violation to the architecture. And so now you've got a real concrete conversation going on. What? Well, hold on, our architecture doesn't work anymore, so we need to change the architecture. Or no, that's not how the intent is you're developing it. Now your architecture is really part of your team psyche, okay? Second thing you can do is build time checking, where the new build can be checked headlessly, if you like. Okay, it can be called command line interface to check that the architecture diagrams, the architecture rules are being adhered to, and the results of that checking can be passed out to whatever the usual audience. Okay, and the idea here is that once it's established, once you start this step 2, it's a continuum. It continuously evolves. Your architecture is part. Every iteration, ideally, you will look at the architecture. Where did it break? Same as you do any refactoring, right? You're going to look at it. What refactoring do we have to do after the last iteration? What refactoring are we going to do to support the current iteration? Your architecture is just part of your code base, okay? And ideally, you really do want to check it ahead of time, because you're going to think, well, if a dependency is going to happen from this cell to this cell next time round, then you should position them accordingly so that the developers know that that's allowed, and they don't get spurious violation reports. Okay, they can get. So you're basically helping. You're doing a little bit of upfront thinking. Okay. So that's the end of the slides. Thank God. Let's have a look at a bit of a demo now. Okay. So I'm going to open up. What will I start? I'll start with this one here. So this is another bit of open source that I've been using for a while for just demos. This is the levelized structure map. As I said, as far as possible, the dependencies flowing down. Sometimes they have to flow back up because there are cycles. Okay, you can't strictly levelize a cyclic graph. Okay, and I can double click to look inside things. Okay, so expand and collapse. I can also group, which I'm going to do now, according to tangles. So pull together tangles for me. It just helps you understand the tangles. And you can see here, my focus first will be to move things around a bit. See if I can take the current physical structure, move things around a bit so that things fall out of the tangled region, fall out of the red zone. Okay. Then I'm going to do it the bottom up. Okay. I'm going to say, well, I'm going to get to a point where actually forget the current physical structure, it's too much of a mess, or I don't care, or it's wrong anyway, and just say, look at the files, and let's see how we can organize those files into a cogent, well-structured containment model. Okay? So step 1 was sort of working bottom up, and I'm just going to fly through these fairly quickly here to give you the idea. And you can see here, so I'm going to focus in on this tangle here, this red zone, okay? And I can see here that util, this is the one that you see all the time. Something called util or utilities at different scopes within your package structure starts using other stuff within that container, okay, within that package. Then you will have tangles because everybody's using util. And if util starts using everybody, you've got a problem, okay? So that's quite a common one. And in this case, it's this depends. Let's see if I can get rid of that dependency. What is it inside util that's using stuff in faces? Okay, it's supposed to be utility. It's not supposed to be doing that. So I can see I've got the server utility, and I'm going to say, well, look, you know, when I select it, actually, I'm just going to say, show me the dependencies when I select something. So now when I select server utility, I can see it has a two-way dependency on faces, but actually has no dependencies on stuff that's in util. Okay, so there's no particular reason for it to be here. Nothing else is using it. So I'm going to put it in there. Likewise, this one here, exactly the same symptoms. And now util has fallen out of that red zone. Okay, just by relocating things a bit smarter. Okay, in the net package here, I can see again. Here's a whole package. The levelization becomes a real guide for you. Okay, because this is sitting up on the top level here, I know that I can move that up because it's only using other things in this other scope. Okay, if I were to say take this message selector here. And say, well, maybe if I moved this up to faces for some reason, would that help things? Okay. Well, no, because it's down in the layers. It's being used by a heap of stuff inside messaging. Okay, so all those dependencies will just follow it up to faces, and I'll have more cyclicity going on. Okay, let me try that. Okay, a whole bunch of feedback dependencies now. Okay, so I won't want to do that. But because this is sitting up at the top level here, okay, I'm pretty sure I can just move that up there. So I'm going to do that. Okay, this one here with this little box of 3. This is a 3 cyclically dependent tangled classes. Okay, tangled classes, they're in sort of orange box or amber box to indicate it's not quite as serious as a containment tangle. And it's generally unavoidable, I think. You're going to have classes using each other. But the point is that those classes that use each other should all be kind of within the same container. That would be our guidance. Okay, you can override all of this stuff, but that would be our guidance. And most importantly, there's no point just taking any of this guy here is where the feedback dependency is going from. But because it's cyclically dependent on all these other things, there's no point me just moving that one up there, because obviously this one's going to depend on it, okay, etc. Okay, so what I'm going to do is I'm just going to grab the rest of those 2 there, move them over here. Okay, now my net has fallen out of the tangle. Okay, and you can see over here we've gained in our over complexity chart has moved down several pixels down. Didn't make a huge impact because in fact most of the code is inside the faces package. Okay, this is tangle of 14. And that's most of the code, so that's where the percentage of the code base number here is most impacted, is at this level here. Okay, so let me just do a bit more, do a quick little bit of moving around here. Util would be another one. What I'm looking for here is where is util using other stuff, and I'm just pulling out things that are being that's using other stuff. Okay, now util fell out of the tangled region underneath it. Okay. Facelets, there's another one. UI debug seems to be causing the problem there, etc. So I can do this kind of thing. Okay, so that's trial and error. You're going to move things to one location, just get them out of there for now. Here's a slightly different kind of category of problem, actually. If I look inside, I think component here. Yeah, here you got component. Actually, everything inside component is being used by other stuff in the tangle. It's not using other stuff in the tangle, but it's being held in the tangle, this input file package, which is using application inside the tangle, is what's keeping all of these guys in. So I might just say, well, look, move input file out. Input file stays in the tangle, but the rest of that package, component package, now fell out of the tangle. Okay, so you can do a certain amount of this. Okay? As you're going along, you may also not just move things around. It's lovely when you can do that and it makes a big impact, but you may actually have to get into what I would call refactoring rather than restructuring. Okay, not just moving and changing imports. The more you can do changing import, my goal in creating these products is that you can do this kind of stuff with minimum change to working code. Okay, and so when you want to just move classes around, fantastic. Okay, if that makes sense, if it still makes architectural sense, that's great, because the risk is low. But you will also find that hold on, the code is wrong. This class is in the right package. This class is in the right package. The problem is that this class is using that class. It's wrong. Okay, so now I've got to do some refactoring. Do I have to create a separate interface? Do I have to split the class out? And what am I going to do here? You can simulate all of that kind of stuff in here too. Okay, so let's say we get to a point now, you can see, did we make any more progress? Yeah, a little bit, another couple of pixels maybe. Let's say we get to a point where I'm going to move to move forward in time. And we've got to a point now where we have this core bunch of stuff. So we were sort of moving things around and we ended up with, there's a bunch of stuff here now that's really tightly coupled in terms of the existing structure, okay? And if I look inside it, I've got tangles within tangles within tangles. I think that's going to take the rest of my life to try and just move things around, okay? So what you can do at that point is say, well, let's forget about the existing structure for a moment. Let me just flatten that out, okay? Just give me the classes now in that area, okay? And you see here in the overview window, we're looking at a relatively small part of a fairly large graph, okay? And in fact, if I look at the chart here, you can see exactly what's happened here. We flattened it out, so we got rid of the containment tangles. So our tangles came down nicely. But it got fat, our fat increased, because now we've got this fairly large container here with a whole heap of classes in it, okay? But anyway, it was a stepping stone. We're just saying, okay, I can't make sense of the current packaging. Let me look at the classes. And here I'm looking at the classes, and I can see maybe I've got some servlet related stuff. So I'm going to say, well, let's start building up a servlet container abstraction, whatever you want to call it. And I can just wrap those through into servlets. Okay, and I can do that kind of thing. And I can go through and gradually build up a containment model from the bottom, keeping an eye on what depends on what. You see those things I pulled together there? They're all sitting up near the top. So I'm getting guidance from the existing dependencies and from the names and from my knowledge of the code and that type of thing. Okay. Or I can just kind of do another shortcut here, which is actually always really fun to do anyway, just to see what it comes up with, which is auto-levelize. And this just tells, there's an algorithm gets run that says, take all the classes in this region of the code base and find cohesive clusters that are not cyclically dependent and create those. If there are a lot of those cohesive clusters, after it's created those, it will create cohesive clusters of cohesive clusters recursively up. Okay. And the great thing is that will find things that are, they're tightly coupled, okay, they're cohesive, and they're acyclic. So taking a structure like this and starting as this is your start point is the way to think of it really, rather than a fait accompli. It's like a suggestion. You can now go through, and for sure you're going to, the names it comes up with are really just to indicate the size. Okay, so you're certainly going to want to rename them. So this is in file, just by looking at the names here, it looks like input file stuff. Inside here, we've got servlet related stuff. So I'm going to rename that as servlets. Okay. And what else have we got? Let's take a look inside here. Okay. Here's a sub package it created here. Now this is all sort of renderer related. It pulled these things together because they're cyclically dependent. It will always put cyclically dependent classes, tangles of classes, into a single container. They won't be spread out across containers because that would make the containers cyclically dependent. So I'm just going to rename that as, what did I say, renderers. Okay. And now I can say, well, look, this one didn't end up in there. It wasn't in the tangle, it was less coupled, but actually it's clearly something to do with rendering. Render hub here, I can see it depends. There's no dependencies from classes in intermediate layers. Therefore, I know I can move that up there and I can do that type of thing. Okay, so I keep doing that. So that's the bottom-up approach, if you like. And you're typically going to do a bit of both, and then we're going to end up with something like, ta-da, like this. Okay. So let's say now we're at a point where I kind of went through this process, whatever, a few hours, and we came up with a containment model. Okay. Now, I have a choice at this stage. I could take this containment model and apply an action list. So I can go here, show me the actions. Here's an action list, okay? And it's sort of categorized into different kinds of actions there, but basically I can export this and then it becomes a checklist in the IDE. I can navigate to the code, make some changes, etc., and I can go through and do that, okay? And at that point, that would be really nice because now my package structure is acyclic. Okay? Or I can say, well, I might do that later or I might not. I don't have to do it immediately. Okay, now this is kind of a key point in a sense, because if you have to go off and maybe change, tens of thousands of files, classes, before you can get the benefit from the product, that's not very nice. But you can actually go ahead now and define architecture on this, and then just feed your refactorings into whatever your workflow is for refactorings. Okay. And start checking the architecture day one if you want to do that. Okay. So the way you would do that is you basically expose part of the LSM, the easiest way. There's different ways you can create these architecture diagrams. You can create them from scratch yourself and drag and drop, go through that whole process. But at this point, when you've gone to the trouble of getting a nice cohesive containment model with a acyclic containment model, the nice thing to do is just expose part of it and say, well, there's a nice picture. Let me define some rules around what I've just exposed here. And I do that by clicking here. Okay, and that's giving me an architecture diagram with basically the same layout, if you like, as the thing that I just took it from, the LSM. Okay, so what I can do now is I can do things like, well, I can get rid of extraneous wrappage here. Just unwrap those. I can add some wrappage here. So I can say, do that. I can wrap that into a box and maybe give that a name. of, what is it? I guess it's external libraries. You know, now, just by doing that, inside here, okay, if any of the code in here, for whatever reason, starts using my main project code here, that'll trigger a warning or an error or break the build or whatever you've set it up to do, okay? So that's, and then we have seen that happen, that, you know, third-party libraries mysteriously change. Okay, other things you can do is, well, you might not want to, you know, you can delete some of the cells that are on a diagram. Okay, you don't need to necessarily, you might say, well, actually I can apply some color just to make it easier to read. Take this one in the middle here, make that a nice pretty green. Okay, you can do that kind of thing. Color is good if you've got a very large code base, you've got multiple components. You might have a top level diagram which have lots of components, but then the color will sort of be a clue for your team who are going to be using these diagrams. You know, they'll join up the diagrams more easily if there's a color associated with a particular component. You can adjust the layering now. The layering is here in the way that it is because that's the way it is today, but maybe it's not right today, okay? Maybe session should be up at this level, okay? So I'm going to move it up and it stays there, unlike the LSM. You can't move the layers around. The layers reflect the dependencies. Now, the dependencies reflect the layering, if you like, in the architecture diagram, okay? So when I move that up there, I now immediately have a couple of violations appearing on my diagram, okay? Other things I can do, let's say here, command and HTTP are on the same row because they don't use each other. Same as these other all four items in this case actually don't use each other, so they're on the same row. But actually I know next time round command is going to need to use, the code in command is going to have to use some code in HTTP. So I'm going to move it up here. Problem now is that I'm actually saying command can use these two, the code in these two cells as well. That's not my intent, so I'm just going to do something, hopefully this is reasonably intuitive. I take those two, I wrap them into a new cell, just an anonymous container cell. Just for the benefit of the rules kind of calculation here, it's saying, you know, these two as a group belong on the same row, i.e. can't use and shouldn't be used by these two here, okay? But this is allowed use this is not allowed use that. I've expressed all those rules just by putting things in a fairly intuitive arrangement of cells, okay? There's a huge amount of rules being expressed by just the relative positioning here. And the final thing I just want to show you is you can do things like, here's an interesting one, session utils. You might say, well, that's within effects. It shouldn't be used by code outside. Now we're getting more into the kind of modularity considerations. Okay, let's make that private. Okay, and you do that by just changing it from public to private here. Okay, a little padlock appears here. And you can see we've got a violation now coming in, although it's a downward violation. It's a dependency on some code that is supposedly internal to this effects component. Okay, so you can do a lot of stuff there. And as time goes on, you can switch back and forth between the LSM. You can sort of say, well, okay, what is it inside session? I can go to the LSM and maybe change the containment model so that this violation goes away. Okay, or maybe the next build comes in and I can do some of the simulation for effects and actually push out, not just trigger problems inside the IDE or inside the build checking, but actually come into the Structure 101 Studio and do some refactoring, do some what if, try different things and come up with an action list that then gets exported. Okay. So finally then, let's just see where that goes one step downstream, which is the Eclipse plugin, which will pick up, it's obviously a different project here, but it's basically picking up the architecture diagrams inside the IDE. So now your developers have these right there, and they're not just diagrams, right? They're being checked. There's semantics associated with these, and every time they make a change, the dependencies that they've created are checked against the allowable dependencies in the architecture diagrams, okay? And if they get any errors, then, and here's an error here, there's one new dependency. It does differentiate between new, there's another thing that I would consider essential, is it differentiates new dependencies from previously existing dependencies. Because I've just checked out the latest version of the code base. Someone else has created 1,000 dependencies. Don't bother me about it just now. Maybe I've got a task to go and fix them, maybe I haven't. But at least let me continue development and not let things get any worse. Okay, so that's the newness kind of thing here. And I can look at the violation breakout here. Top level architecture is new. Where is that coming from? And it sort of takes you there and you say, oh yeah, okay, I shouldn't do that. Or I go up and I beat up on the architect, whoever's wearing the architect hat. Okay. And that's it. I think that's all I want to talk about. There's the action list, if you like, I could be going through this action list. Whenever actions are undertaken, when I load it back into Visual Studio, I see those actions in the list get grayed out as the code base starts to align itself with my containment model. Okay, at this point I'll pause now for a couple of minutes of questions, if anyone has any. Yeah.
What is the biggest project that? Oh, thank you. What is the biggest project that you actually used the Structure 101 on?
Into the tens of millions of lines of code. Yeah.
And how long did it take?
It's still ongoing. The one I have in mind actually is, I think it was about 20 million lines of code we looked at recently, and it was interesting. I think this, I've looked at several very large code bases of this sort of magnitude, and what you'll often get is something very similar, which is you home in very quickly on the big tangled mess, and when you say you've got a big tangled mess here, you hear back, yeah, that's where we get all our problems. Okay, so that's always good to hear. These guys had a big class tangle of 4,000 classes. Okay, all cyclically dependent. So anything changes in there breaks everything up. So those guys are now working on busting that up. That's a really hard job. Okay, busting up a big, multi-thousand class tangled mess. Okay, that really that's hard work. You can helps dramatically being able to understand what's depending on what and how. Okay, so there's an activity going on there. There's also an activity going on that sort of keeps the wraps on that and defines an architecture around the rest of it, so that they can take their core code base and have it they want to break it up basically so that the client applications don't all depend on if anything changes in the core, everything else changes. There's a finer granularity. So that's going on. And the other thing that's going on is organizing the hundreds of jar files into higher level components. Okay, and putting some constraints on that. So this slowing down the growth of the dependencies. So that's been going on for a while. I would say that's going to go on. I think their plan is to have it sort of, to the next major phase of improvement. I mean, it's probably never going to be finished in a sense, but 9 to 12 months on that one. We've had large C++ code base I'm thinking of, which was done in completely restructured and acyclic in that sort of period of time, where you took a team of guys, basically, I think it was like half a dozen or so guys who were focused on a project to restructure it. So, that's very large. And then after that is how long is a piece of string? Like how big is the code? How tangled is it? Etc. Yeah.
And for the time when they are working on it, beside expand, collapse, and filtering, is there anything that they can do to actually focus on a smaller area of their code?
Well, yeah, there's various ways you can set up your project to include less code, would be one. So you can exclude stuff from your project. There's project settings to do that, what's included, what's excluded. So that's more of a sort of a, let's say, at a session level. Okay, when I'm working, I want to do that. There's a lot of transient stuff to do with filtering and hiding and what have you that will help you, just get rid of the clutter for what I'm doing at a very transient level, sort of for the next few minutes. And there's quite an elaborate, it's like a filter stack that allows you to go down, filter a bunch of stuff, filter it more, do some fixing, then go to the previous filter and that type of thing. So that is a key point, is being able to just get rid of all the noise so you can focus in on the stuff that's of interest.
Thank you.
Okay. Yeah.
Hi. What about backward compatibility? Because moving classes from packages to packages, when you're doing kind of framework, then people which are using that framework would wipe you out totally from planet Earth, I believe.
Yeah, I mean, there's no easy answer to that. I mean, so you try to take the answer, you kind of at least flag the things that you don't want to move and don't move them. Or, well, actually, there was one large financial organization who was looking at doing this, and I said that, presume this is going to be a problem for you. And he said, well, no, well, tell me. I mean, it's a matter of like bang for the buck. But you know what he was planning to do was write scripts, Eclipse scripts that say move these things around. He's going to create a new version of the refactored kind of core code base with lots of applications using it, and then distribute the script along with the release. So he's going to say to all the development teams on each of these of the client, if you like, projects, this new version is available, right? We've decoupled it and we've restructured it. Okay, so things are in different places. If you run this script, it'll simply move. It'll change the references to a different location. Okay, so it's actually quite a simple script. So I mean, you know, on the scale of a large project, it's not much effort to do that. Yeah, so that's, I suppose, the most. That's the most. I suppose that's the most. What would you say? Imaginative kind of way to do it that I've seen. Most ambitious. Others, I suppose, you could just go through and start deprecating and do that kind of usual thing and move it to a different location. But there's no. Yeah. Thanks. The question is, how do you integrate with CI? It's the integration is through basically a headless version of the technology that takes a command line interface. So you just build it in. We've got plugins for Maven, actually for Sonar, Hudson, that type of stuff. And you just what it's doing is it's doing a call without firing up the UI. So it says, you do your build, and then you say, now do an architecture check. And it does the check, and then you can tell it what you want it to do. So you can, you have a lot of granularity there in terms of, do you want to just break the build if there are any violations, or if there are new ones, do you want to break the build or just set it to unstable? You've got all those kind of options. But it's basically command line interface is the solution there. Okay. Last question?
Okay, so this time with the mic. How do you keep those dependencies? Is it like I separate XML file, I can take a look in like my preferable editor?
Yeah, so how do we keep the dependencies? Well, first place we get them from is from actually the bytecode, not the source code. Okay, so that's where we get them from, and that creates a model. So you can do that continuously if you want. You can also save off a snapshot of all those dependencies in what we call a repository, but file-based is actually an XML-based repository system, which has the advantage, and it can be web-enabled and all that good stuff. But that's the advantage of that is it now allows your team to do comparisons. So you can say, well, here's a baseline that you're going to do comparisons against. I don't want any new violations from this baseline. Then within the IDE, they can point to that. Within your build check, you can point to that to do that checking, right, against a previous baseline, if you like. And it's also really good to be able to open up a project with a known, you don't actually have to, all the configuration management issues are gone because someone has done a publish of the snapshot, structural snapshot. So you can kind of browse that remotely. So that'd be the two, I guess, the two sources of the dependencies, the bytecode itself and the XML repository. Okay, well, thanks very much. And I guess we should break now give you time for coffee before the next session.